Hello guys, and welcome back to the CCNA video series brought to you by ABY Design and Tech. In this video, we're going to look at the basics of binary numbers. So the learning objectives: to understand the basics of binary and to understand how to translate IP addresses into binary. And you may be wondering yourself, why are we focusing on binary? And that's because computers read IP addresses in binary. Secondly, we use binary when we're subnetting, so it's important to understand how binary works. So before we dive into binary and how it works, etc., let's look at decimal numbers because we grow up on decimal numbers and how to use decimals. So everyone's used to decimal numbers. 1 plus 1 is 2, etc. We all know that. However, with decimal, it's a base 10 numbering system, which means that each column increments by a power of 10. So as an example, we start off with our units down here. Example 1, 2, 3, 4, 5, 6, 8, 9, etc. And then as soon as we hit 9 and we move over to 10, we are moving over one decimal column. So now we're moving over 10 to the power of 1. So that is obviously 10. Then we have 10 to the power of 2, 10 to the power of 3, 10 to the power of 4, etc. So it's a base 10 numbering system. And obviously each column we have can have any value between 0 and 9. As an example, the number 353. That's made up of 3 hundredths. So we put a 3 over here. It's made up of 5 tens, so 50, and made up of 3 units. So that's how we would break down a decimal number. If we were going to break down every single digit of a decimal number, we would do it moving from left to right. Left would be the highest power of tens. In this case, it's going to be hundreds. The rightmost side is going to be the lowest power of 10. So as we move from left to right, the power of tens decrease. And so to really draw this home, let's break down some more numbers. So as an example, decimal 350. That's made up of 3 hundreds, 5 tenths, and 0 units. So 350. Okay, let me just rub this out quickly. And then we've got the decimal number 9. Pretty simple. That's just made up of 9 units. So that is 9 over there. Equals 9. Then let's look at this decimal number down here, 2568. That's made up of 2 thousands, 5 hundredths, 6 tens, and 8 units, giving us 2568. So when we're talking about decimal numbers, the reason why we never have to break them down like this by column is because we're so used to them and they're so natural to us. They make sense. Now, why will we be breaking down decimal numbers? Because it helps get us ready for binaries. So obviously with decimal numbers, we saw how if we really wanted to dig deep, we could break each individual digit of a decimal number down based on a power of 10 column. So obviously the rightmost is going to be the lowest power of 10. The leftmost number is going to be the highest power of 10. And we saw how we can break down numbers like 350 into 300s, 5 tens, 0 units. Now, with binary, it's a numbering system that uses base 2. So each column increments by a power of 2 and can have one of two values. It can have 0 off or 1 on. And each digit is known as a binary bit. Now, the reason why I drew out the base 10 column system is because it was important for us to see how with decimal numbers, how we could break them down by using base 10 columns. We wouldn't need to do that in real life because we're so used to decimal numbers. However, with binary, because they go up in powers of 10, it's a base 2 numbering system. We have to draw a column table, otherwise we would get confused. Now, with binary, let me use this column system here. Let's say I wanted to represent the number 5. Okay, as a binary number. So all we would do is moving from left to right, we would put a 1 under the column that we need to make up that number, or we'd put a 0 if we don't need that. As an example, we don't need that, we don't need that, not that either. So we obviously don't need these, okay? Now, 4. Do I need 4 to make decimal 5? Yes, I do. So I put a 1 there. Do I need a 2? Well, no, because I've only got 1 left. Do I need a 1 to make a decimal 5? Yes, I do. So decimal 5 in binary is 1, 0, 1. So as you can see, using the base 2 numbering system, we were able to take a decimal number and represent it in this binary format. And the reason why we have to draw out the column table is because moving from right to left, each column is going to increment by a power of 2. So first we start off at 2 to the power of 0, which is 1, because anything to the power of 0 is 1, then 2 to the power of 1, which is 2, 2 to the power of 2, which is 4, etc. And then obviously we move up. Now, because we're not used to using binary and representing numbers in binary format, we have to draw this column system because it helps us. And it's literally as simple as this. Whenever we see a decimal number, or let's say 100, all we do is think about, oh, okay, moving from left to right, based on each column, do I need that column or the number, that number in that column, to make the number 100? So if I try to translate this to binary as an example, let's rub this out. Bring up my pen. I need 64, okay? So 100 take away 64, that is going to be 36. Okay, I need 32, okay? That leaves me with the number 4. I don't need 16. I don't need A. I need a 4. Don't need a 2. Don't need a 1. So now, 100 in binary, that is 1, 1, 0, 0, 1, 0, 0. So as you can see, binary is actually very, very simple. All we do is draw out our column table. Okay, and then we just move from left to right and say, do I need this number to make up this decimal number? If I do, so think of it like this. Does this number fit into 100 or fit into my decimal number? So does 1024 fit into 100? No, it doesn't. Does 64 does? Yes, it does. So then I put a 1 next to 64. Does 32 fit into 64? In a 36, yes it does, so I put a 1. Does 16 fit into 4? No it doesn't. Does 8? Does 4 fit into 4? Then yes it does. Okay, so as you can see, converting from decimal to binary is very, very simple. We just draw out our column table, and then we just put a 1 next to the numbers we need, and put a 0 next to the numbers that we don't need. So just going through some more examples very quickly. Decimal 300. Okay, how would you represent that? So obviously moving from left to right, we need 256. So 300 take away 256, that is going to be 44. I don't need 128 because that doesn't fit into 44. Don't need 64. Need 32. That leaves me with 12. Don't need 16. Need 8. That leaves me with 4. I need a 4. Don't need a 2. Don't need a 1. So now 300 in binary is 1, 0, 0, 1, 0, 1, 1, 0, 0. Now let's look at 21 in decimal as an example. 21 in decimal is as follows. So I need a 16 to make 21, obviously, so that's going to give me with 5. I don't need an 8. I need a 4. I don't need a 2. I need a 1. So now 21 in binary is 1, 0, 1, 0, 0. And I know I keep repeating this, guys, but as you can see, binary, converting from decimal to binary is pretty simple. We just list out the decimal number. We draw this column. So as we move from right to left, we increase by power of 2. So 2 to the power of 0 is 1. 2 to the power of 2 is 2, etc. 2 to the power of 4 is 16. 5 is 32, 64, 128, etc. Once we've drawn out enough columns, they're moving from left to right. We look, oh, okay, do I need this number to make up the decimal number that I'm trying to make? Now, moving on, we've seen enough examples, okay? Why is this important? So like I said, to understand subnetting, you need to understand how to convert IP addresses and subnet masks into the binary format. Because with subnetting, it's going to be the binary that we're going to be using to actually subnet IP addresses. Now, it's important to know that an IP address, I've mentioned this in an earlier video as well, an IP address is made up of 32 binary bits divided into 4 sections of 8 bits. Each section is known as an octet. Now, if you do our binary maths, if we have 8 bits, if all of the bits are set to 0, it means that we have decimal value of 0. If all of the 8 bits are set to 1, then we have a decimal value of 255. Hence the reason why each octet of a IP address can be between 0 and 255. A subnet mask is also made up of 32 binary bits, divided into 4 sections of 8 bits, and each section is known as an octet. So we've got subnet mask octets and IP address octets. Now, computers read IP addresses in binary. You see, the IP addresses in decimal are just for us humans to read and for us humans to understand, because we work so much better reading IP addresses in their decimal format. Can you imagine if all the IP addresses listed were listed in the binary format? Every time we looked at an IP address, we would have to break out our binary chart, draw out our columns, and then work out that number. It's so much easier to just represent the IP addresses in decimal format so humans can read them easily. So to really drill the time, let's actually now take what we've learned about binary, obviously how to convert decimal numbers into the binary equivalent. Let's take this and apply this to IP addresses. So whenever you want to convert an IP address into its binary format, we go octet by octet. So first we start this first octet, then the second octet, then the third octet, and then the last octet. And whenever you convert IP addresses, remember, each octet is 8 bits. So we draw out the first 8 powers of 10. So 2 to the power of 0 is 1, 2 to the power of 1 is 2, 4, 8, 16, 32, 64, 128. So if I count from right to left, 1, 2, 3, 4, 5, 6, 7, 8. So the first 8 powers of 10 brings me up this column. So whenever we are converting IP addresses into binary, always draw out this column. And then we simply say, okay, moving from left to right, how do I make up 192? So I need 128. And that leaves me with 92, take away 20, 72, take away 2, okay, that's dealing with 64. And I need a 64, and that's it. So now, 192, and it's important to know that with binary numbers, if we have any leading zeros on the right, we cannot omit those, we have to include those. If we had leading zeros on the left, then we can omit those. So essentially, whenever you see a 1 in binary, you have to include all of the numbers after that 1, okay? So now 192 in its binary format is 1, 1, 0, 0, 0, 0, 0, 0. Let's convert 168. So let me just rub this out. So 168 again, we're going to go with 128 because obviously that fits into 168. That leaves us with 40. Okay, 64 doesn't fit into 40. 32 fits into 40. So that leaves us with 8. 16 doesn't fit into 8. 8 obviously fits into 8. 4, 2, 1. So obviously we don't need the last 3 binary bits to be set to 1 to be turned on, so we set those to 0. And that gives us 168 in binary is going to be 1, 0, 1, 0, 1, 0, 0, 0. Now let's convert 200 into this binary equivalent. So again, let me just rub these out to make myself some space. Okay, 200, we need 128, that fits into 200, so take away 100 is going to be 72. 64 fits into that as well, so 64, that's going to be 8, so it leaves me with 8. So now we've got 0 for this, because 32 doesn't fit into 8, 16 doesn't fit into 8, 8 obviously fits into 8, 0, 0, 0. So now 200 in binary is going to be 1, 1, 0, 0, 1, triple zeros at the end. And obviously, because we have to include 8 bits, so it's important to know that with IP addresses, because we have to include all 8 bits, it means that the number 1 is obviously just going to be 7 zeros with a 1. Because an IP address is 8 bits in length, we have to include all 8 bits for every single octet, even if we start with zeros. So when I say omit zeros, I'm talking about when you just want to convert any decimal number to its binary equivalent. We would omit the decimal zeros. However, when converting IP addresses into the binary equivalent, we have to include the leading zeros as well. So that's going to be 4, 5, 6, 7 with a 1 at the end. And now 192, 168, 201, that is the binary equivalent. So with me, you have just converted your first IP address into its binary equivalent. And to practice this, to get very good at this, before you progress any further in the series, literally just write down IP addresses. Just go through one IP address, 2 IP addresses, practice with all sorts of different numbers, all sorts of like class A, class B networks, class C networks, etc. Focus with all sorts of IP addresses. Draw out this table. So the table will always be the same, and literally just go through every single octet of the IP address and convert it to its binary format. That's how you're going to become really good at converting IP addresses into binary. Now moving on to subnet masks. Well, subnet masks are actually, the class for subnet masks are going to be easier because subnet masks are literally just binary ones followed up by a set of binary zeros. So as an example, 255.000, that is 1, 2, 3, 4, 5, 6, 7, 8. Because obviously, if all of these bits were set to 1, that would give us 255, then the number 255. And obviously, the rest of the subnet mask is just going to be binary zeros. So 4, 5, 6, 7, 8, etc. You get what I'm saying. Now 255, again, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, followed up by 1, 2, 3, 4, 5, 6, 7, 8, followed up by the rest of zeros. Now, this is going to be 1, 2, 3, 4, 5, 6, 7, 8 again. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Now, the reason why the subnet mask is made like this, and it's made like this for a reason, and this is how computers work out which part of the IP address represents your network and which part of the IP address represents your host. So, whenever we type in the IP address and subnet mask in decimal, what your computer will do is translate both those numbers into binary. Whenever we see a 1 in the subnet mask, it means that bit of the IP address represents our network. That means that those bits for any host within the network have to be the same. So as an example, this subnet mask, because the first octet is all ones, it means that the first octet of the IP address represents the network, and that cannot be changed. So any device within that network, their first octet of the IP address has to be the same. With a 255.2500 subnet mask, the first two octets, because they're all set to ones, the first 16 bits of the IP address, or the first two octets, represent the network, or the network part of our IP address. So as an example, if I have the IP address 192.168.2.2, it means that every device in my network has to have the first two octets have to be set to 192.168. The last two octets can be anything because they identify the host. Now, the subnet mask 255.255.255.0, and you guessed it, is the first 3 octets of the first 24 bits. So if you count the bits, so we've got 8 bits plus 8 bits is 16 plus 8 bits is 24. The first 24 bits of the first 3 octets represent the network part of our IP address, and every single device in the same network has to have the same first 3 octets. Now these subnet masks I've listed to you, these are the class 4 subnet masks, which come as class A, B, or C networks. So class A would use this, class B would use this, or class C would use this. Now, with subnetting, I'm not going to go into depth in this video, but just a very, very quick overview. Subnetting, what that allows us to do, that allows us to create our custom subnet masks. So a subnet mask is valid as long as preceded by a contiguous set of ones and a contiguous set of zeros. As an example, this would not be a subnet mask because we're mixing ones and zeros. However, something like this, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, that would be a valid subnet mask because we have a consecutive string of 10 ones followed up by 32 blocks, followed up by 22 zeros. Now that would be a valid subnet mask. And the reason why we have to know how to convert from from decimal into binary, because when we're actually building a custom size subnet masks, when we're actually subnetting, we are going to be first creating the subnet mask in binary, and then we're going to need to be converting that from binary into a decimal equivalent to find out what our subnet mask is in decimal. Now, when we're calculating our IP address range for that subnet, we're going to be converting the IP address into binary, okay, and then we're going to be working out the binary maths, and then we're going to be converting that back into decimal. Again, we will see this as we start to get more into subnetting, but just for now, this is just it's just an introduction to binary numbers and how to convert from IP address our IP address from decimal into the binary equivalent. So that is binary numbers completed. And again, I urge you, take IP addresses, take subnet mask and convert them into binary. And actually, I'll tell you what, before we go to the next video, I want you to create your own subnet mask. Remember, the subnet mask, all it has to be is a set of consecutive ones on the left, followed up by a consecutive block of zeros. So you can have 2 ones and the rest zeros, 6 ones and the rest zeros, 20 ones and then the rest zeros. Literally just create your own subnet masks. Remember, break them up into four sections of 8 binary bits. Create your subnet masks in binary, and then using that table that I've shown you, convert them into the decimal equivalent. If you have enjoyed this video and you would like to see more videos like this, then please subscribe to my channel, and thank you very much for watching.